Hi everybody, we're in Unit 4, we're on Day 4 notes. The title is Solve by Factoring, and then today we're adding on a little bit by sketching the graph. So after we factor it and we solve it, get those x-intercepts, we're going to be able to plot them. Maybe figure out the shape on your own, but sometimes we can use our calculator to help us. First blank on the top says, where can you find the solutions to an equation on the graph of the function? Well, first off, this word solutions has a couple other words that mean the same thing. We've talked about roots. We've talked about x-intercepts. And the last word we talked about that means the same exact thing is zeros. So if you see any of those, it means the same thing. We're really looking for the x-intercept. So where can we see those on our graph? We can see those on the x-axis because it's where it's touching or where it's crossing the x-axis. How can you use what we know to sketch the graph of the function? I'm going to give you a couple quick visuals here. The first one I'm going to give you is a little mini graph, and I'm going to give you a line. This is a linear function. If it's a linear function, we have something like f of x equals x, something where the exponent is to the first power. We've seen those a lot, algebra 1 maybe. Then the other one we have is something where it looks like this U shape. This is a parabola. We've done these a lot. These are quadratics. This is something where it's f of x is equal to x squared, so that exponent is to the second power. And this is the shape that would then make. Another one we've seen is when it looks kind of like this little S shape. This is what we call a cubic function, and this is f of x is equal to x to the third, where that little exponent is to the third power. The last one we've seen is it kind of looks like a W. Kind of like this W where it has two kind of humps, bumps or whatever kind of underneath there. This is called a quartic. And this would be where f of x is equal to x to the fourth. I think of quartic as like a quarter, and there's 4 quarters in a dollar. And that's the graph for that. So you'll see in a second I'll be referencing the degree. So linear has degree 1 because of that little exponent. Quadratics have degree 2 because of that exponent. Cubic is degree 3, and there's the shape. Quartic is 4, degree 4, and then there's the shape. So just a little reference to that. There's other ways that we would know, but that's kind of a big one. Also, if you're really stuck, you can't remember, but you have your calculator sitting in front of you, I think a good way to kind of see the shape is to put it in your calculator, graph it, look at the visual, see the shape, and then go from there. Example 1, we have A, B, and C. We're going to start with A. It says solve by factoring the GCF. So that's keyword there. You're just doing the GCF and then sketch the graph. So I'm looking for something to take out. The GCF is either a number or a variable. Sometimes it's both. If I'm looking at this first problem, I have x to the third minus 7x. What they have in common is just a single x. That leaves me with x squared minus 7 on the inside. What I need to do next is the ZPP. Take each piece with an x, set that piece equal to 0, solve. This piece is already solved, so I have x is equal to 0. That one was pretty easy. This other piece doesn't look so easy. I take it, I set it equal to 0, and I'm going to have to start solving for x. So the first thing I want to do is subtract 7 to the other side. I get that x squared is equal to positive 7. Then I got to get rid of this exponent of 2. So I square root both sides. When I insert in a square root, I have to insert in a plus or minus symbol. This plus or minus symbol always goes there. Then I'm double checking to make sure that this square root can be broken down. Maybe, maybe not. In this case, it cannot. But I have two answers here. My positive square root of 7 and my negative square root of 7. So, getting a little picture, let me kind of adjust so we have some space. I'm going to want to form an x and y, and I'm going to need some tick marks. If I just simply type into my calculator the square root of 7, the square root of 7 is approximately 2.65. So it's a decimal. I have a positive 2.65 and a negative 2.65. So I'm going to do about 3 tick marks. I need to put 0, I need to put positive 2.65, and I need to put negative 2.65. Then, this is what I'm talking about with the shapes of the graph. I see in the very beginning where I'm highlighting yellow, it has something to the third power. That means it's going to look something like a cubic graph, a cubic shape. There are no bounces, so it is going to hold that shape and it is going to pass through all of the points. So it looks like that kind of S shape. If you had no idea how to graph that really confuses you, it makes no sense, then use your calculator. You would type this original function into the calculator and get the picture from there. Make sure when you graph this, put some tick marks on there. Plot the points. If you just have a graph floating in the middle of nowhere, I'm not really sure how I would grade that. Make sure it's very obvious where your points are at. Next problem, problem B. I'm looking for a GCF. I see that I can take out an x. I'm left with x squared plus 18, and it equals 0. I'm going to take each piece, set each piece equal to 0. This first one's really nice. I get that x is equal to 0. The second piece, I'm going to have a little bit to do on it. I have x squared plus 18. It equals 0. I want to get x by itself, so I need to subtract 18 over to the other side. Then I need to square root both sides. When I am inserting in my very own square root, I have to do my plus or minus. So I get that x equals plus or minus the square root of negative 18. First off, the negative symbol is no good. Also, the 18 can be broken down a little bit more. I can split that up into 9 and 2, and I can split that up into 3 and 3. My matches come on the outside, my leftover stays under. So I'm going to have x equals plus or minus, my match of 3 comes to the outside, my I from the negative comes on the outside, and my root 2 stays underneath. This is an imaginary solution, so I'm just going to draw a little arrow here. This is imaginary. How do I know it's an imaginary? There's an I for imaginary. I'm going to put in parentheses, we can't graph these. They're imaginary. We can't see them. Okay, we can't graph these. That's okay. We know it's there. It's a solution. We just can't see it on the graph. So really the only thing I can see on my graph right here is x equals 0. So I'm going to take a quick second, form my x and y, and I'm going to plot my 0. I know it is a cubic function because it's to the third power, so I know it holds some type of shape like this. So that's about all I can do at this point. Problem C is very similar. I would pause the video at this time and try it out. It looks like you will get the solution of x is equal to 0 and x is equal to 4. Your graph is going to look like a parabola that looks something like this. So make sure you're able to do those on your own and you can get that answer. Otherwise, moving on to our next type of example, example 2. Solve by factoring, but the method of grouping. So different way, different method. This is what I like to do. Take the first two, chunk them together. Group them. Take the second two, group them together. Look at my yellow piece. Out of my yellow piece, I'm looking for a GCF. I take out an x squared. I'm going to be left with x plus 1 on the inside. Out of my blue piece, take out your GCF. I can take out a 2. I'm going to be left with x plus 1 on the inside. Right now, what needs to happen is these yellow pieces that I just underlined have to match. If they don't match, then you need to go back and fix your problem. My pieces that I circled in the front, the GCF, drop down. They form their own little binomial. The underlined piece drops down once. Yes, I know there's 2 of them, but only one of them dropped down. When you have that, that is grouping. That's the process. But from here, we're still looking to solve. So I need to take each piece and set each piece equal to 0 so that I can break it down and solve it. So this first one, I'm going to subtract 2. I square root both sides. I put in my Hopefully you said plus or minus. Then I have x is equal to plus or minus I root 2. So there's one of them. My other one, I set equal to 0. I solve for x. I get that x is equal to -1. Okay, that one's really nice. Once again, in blue, that's imaginary. Can't graph it. The part in red, that's fine. I can graph that. That's just a normal number. So when I go to split this up into my graph, I want, let's do like 2 tick marks in each direction. I want to plot it at -1. This blue one I cannot plot. Let me look at the kind of function I started with. The highest exponent, the degree I have, is to the 3rd power. That means it's cubic, so it looks something like that shape. Okay, again, you could type this original function into your calculator, graph it, see the picture, you'd see something like this. Let's try to fit in one more. I'm going to take the first chunk and the second chunk. My yellow chunk, I can take out an x squared. I'm left with x minus 1. On my next chunk, which is blue, I'm going to have to take out the negative from that negative sign in the middle and take out a 4. So I'm going to be left with x minus 1. Then I need to double check that these green pieces match. When they match, I can proceed. This first chunk, x squared minus 4, those form together. The next piece with my yellow, I drop down one of them. Again, I know there's 2, but only one's allowed to drop down. Then I'm going to take each piece, see if I can break it down. I'm going to solve this first piece. Take it, set it equal to 0. I'm solving for x. I get that x squared is equal to 4. Oops, let me rewrite that. X squared is equal to 4. I'm going to have to square root both sides. I need to put in my plus or minus. I get that x equals plus or minus 2. The square root of 4 is 2. Then the other piece, I take it, I set it equal to 0. I get x minus 1 is equal to 0. I add 1 to both sides, and I get that x is equal to 1. Both of these are numbers, positive 2, negative 2, and positive 1. I can graph all of those. So I need to form my graph. Oops. And I need to put, let's do about 3 tick marks in each direction. I plot positive 1, I plot positive 2, I plot negative 2. I look at what kind of graph I have. It's to the 3rd power. There is no bounces, so it passes through all of those. And I mean, my graph is just a sketch. It's not that great, but that is the general shape. If you are lost or confused, please consider coming into the resource room for help. The resource room is room 236. Otherwise, pause the video and maybe watch it back a couple more times so you can understand. The first couple were on the GCF and then solving. The second couple were on the method of grouping, and then we solved from there.